Kirkman. Hello and welcome to 7.2. We're going to be looking at multiplying polynomials and monomials and trinomials and all the nomials. We are in our student companion on page 142 and 143. Let's go. So our first example here is just looking at multiplying a monomial, so a single term, and a trinomial, or three terms together. This we're going to do using the distributive property. It works very similar with polynomials in the same way that it works for real numbers. So all we are going to do is just distribute this negative 4x to the third to each term inside my parentheses, or monomial. So if I go down here, you can kind of see here I rewrote them because they kind of jump from here. They show you the negative 4x to the third times x squared, and then they jump straight to the answer. But as a review on this side, the way that we multiply terms together is you multiply your coefficients separate from your exponents. So here, if I'm just focusing on this one right here, and you can see as I go down how that looks, I separated it into the negative 4 and the 3, and a 1, because that's the coefficient of x squared, and an x squared. Then I rearrange them very similar to combining like terms, except this time we're multiplying, into my coefficients here and my exponents here. Remember, when you're multiplying exponents, or multiplying powers, you add the exponents, and that is how they got negative 4x to the fifth, okay? Over here, you can see that we did the same thing. I didn't write it out for this because a lot of this we can do in our head, but just so you can see how I got this answer down here, we did negative 4 times 3, coefficients multiplied together, and then x to the third power times x to the first power. So we added those exponents and got x to the fourth power. Now, at this last one here, you can see that the term I'm multiplying by, I have one term with a variable and one term that's a constant with no variable. So I'm just going to multiply the constant and the coefficient. Negative 4 times negative 4 is positive 16, and then my variable stays the same. The way that we have them written here is in standard form with my highest degree first, from highest to lowest, and that would be my final answer. Please also notice that the answer to these polynomials is a polynomial itself. It would be very rare for you to multiply two polynomials and not get a polynomial. It could happen, but you're most likely going to end up with an answer that is just a different expression, an equivalent expression, that is also a polynomial. Okay, so go ahead and see if you can do this. Use the distributive property and your understanding of multiplying terms, multiplying exponents to find each product. On this next example, we are going to take a look at how multiplying binomials can be like multiplying a two-digit number. And if you look at our title, we're going to use a table to kind of help us, okay? And I'm going to show you a couple different ways, and they might show you some ways here, but we're going to show you two. So if I'm multiplying two numbers like 15 and 18, that is very similar to multiplying these two polynomials or two expressions, x plus 5 and x plus 8. And we can use a table for both of these. So again, going back to prior knowledge, you should know that the expanded version of 15 is 10 plus 5. We're just breaking it down into its place value. And the expanded version of 18 is 10 plus 8. When I multiply traditionally, I have to multiply my 1's together, my 1's of the 18 by the 10's of the 15, the 10's of the 18 by the 1's of the 15, and the 10's together. So you can see with my colored little loops here, I have to do 1, 2, 3, 4 different multiplication problems, and then I'm basically just adding them together. Another way to do this would be to make a table like the one shown here, or the one I kind of started over here. If I separate my information into expanded form, and they show you that here, and I do 10 and 8 times 10 and 5, you can see they're multiplying their 10's together to get 100. So I'm going to do that over here on my little guy. Oops. 10 times 10 is 100. They're going to multiply 10 times 8, which is 80, 10 times 5, which is 50, and 5 times 8, which is 40. Then what do you do when you're done is we're going to take our answers that are kind of inside the middle part here, and we're going to just add them together. And that's kind of the same thing as what you've done when you're multiplying in the standard algorithm. You're just going to add the 100, the 80, the 50, and the 40 together, keeping those place values, and you would get 270. Now, if you understand this with just numbers, then you should be able to relate it to when I'm multiplying two binomials or polynomials, or two sets of expressions. So here, I separated them into their expanded form. We took the x's and separated them from the constants. And then we're going to multiply. X times x is x squared. 8 times x is 8x. X times 5 is 5x. And 8 times 5 is 40. Then what they do is they add them all together. So using that table, they can then put these pieces of information together. X squared plus 8x plus 5x plus 40. Combining the like terms, which are my x's, I'll get x squared plus 13x plus 40. And this is my expression, my polynomial answer. Okay, that is right there. So it says you can multiply both binomials and two-digit numbers in expanded form using the distributive property, which is what we kind of did here. What I also want to show you, because you can make a table for those binomials, that is one method of a way that you can multiply, if that makes sense for you. I think it's a super handy way to multiply so that you don't forget anything inside. You can easily remember to multiply them all, and then just add them all up like we did up here. However, there is another way that we kind of learned when I was growing up. I wanted to show you, and they might have another example here, but I'm going to show you a little bit earlier as well. If you do not want to use a table, you can do something that is called foiling. It stands for first, so FOIL stands for first, outside, oopsie, inside, and last. So the table works the exact same way, and it's super helpful for organizing your information. But if you wanted to do this more in your head and you didn't want to make a table, then you could FOIL instead. And I'm going to show you what that looks like. I probably should have done different colors, but that's okay. So we're going to do my first ones first. So I'm going to take the first term in each of my parentheses, and I'm going to do x times x. That's x squared. Then I'm going to go ahead and do my outside. So outsides are my first and my last, kind of those outside edges, as you can see, outside edges. And I'm going to do my x times my 8, and that's going to be 8x. Then I'm going to go ahead and take my inside. Oh, I should have underlined here. This one. Boop. Okay, inside is going to be purple. Inside is just that. It's the numbers that are inside the middle of my multiplication problem right here. So I'm going to do 5 times x plus 5x. And then I'm going to do last. First, outside, inside, last. So the things I'm going to do last are going to be the last two numbers in both of these parentheses. So I'm going to do 5 times 8. And that's 40. And you can see we get the exact same expression that we did before. I can now combine the like terms again. Okay, and I'm still going to get x squared plus 13x plus 40. So you can use a table or you can FOIL. All right, the next part here is looking at a real-world application of trying to find area of a composite shape here. So we want to know the area of this green rectangle. We know that this section of the green rectangle is 2x, this little piece is 1, this section here, this length is x, and this length is 3. So because we have these compartmentalized, we know that one side of this rectangle is 2x plus 1, so that's where they're getting this expression here. They know the other side of the rectangle is x plus 3. So here we have two binomials that we need to multiply. We can make a table or we can FOIL, and I'll probably show you a little bit of both. So here they're going to show you a table version. They have 2x plus 1 times x plus 3. So they set up, they expand, break apart their expressions, 2x and 1, just like it was in the area here, and x and 3, just like the rectangle, and they're going to multiply. 2x times x is 2x squared, 2x times 3 is 6x, 1 times x is 1x, and 1 times 3 is 3. This is using our table. The next thing that we're going to do is just combine all of these together and put any like terms together so you can kind of see. I'll do it over here. You're going to get 2x squared plus 6x plus x. That's why those x's are blue, because it's showing you like terms. And then they put those together in order to get the 7x that you see in the answer down here. Okay? What I'm going to do over here is I'm going to show you how this works with foiling in case you didn't want to use a table. Perfectly fine to do both. So if you didn't want to use your table, you would take your 2x plus 1, and you would take your x plus 3, and we would FOIL. We would go first, 2x times x is 2x squared. Outside, 2x times 3 is 6x. Inside, x times 1 is x. And last, and that's 3. And then you get the exact same answer, 2x squared plus 7x plus 3. All right, so go ahead and use whatever method you want. If you're going to use a table, they're kind of already set up in a table manner, so that would be easy to do. Or if you want to try to FOIL and find those answers. All right, look at this. In the next example, they're showing you how to FOIL, but they don't use the words FOIL. It's basically using distributive property. As you can see with my arrows, it is like distributive property. They're basically taking the 2x and distributing it out, taking the right to each of these things, and they're separating it out. Honestly, you are welcome to write this down. I think it's easier to FOIL. So if you would like to write down this example, that's great. Otherwise, stick to FOILing, and you'll be able to get the right answer every time. All right, so again, use FOILing or use distributive property if you would like. You could also still make a table if that works for you, but see if you can find the answers to these two problems. All right, all of the ways that we have shown you are super helpful in solving different types of problems. Sometimes when you're multiplying a trinomial and a binomial, a table might be easier for you to see because there isn't a first, outside, inside, last like there was in our previous problems. So if I'm going to use this table, you would just fill in the table by putting each term or monomial into its own box. One of them across the top and one the other expression down the side. Then you would just multiply and find the little cross multiplications. I'm sorry, that's back over here. It just says to multiply each row and column to get answers. Then you're going to combine those like terms, writing that all out, combining your squared x's with squared x's, your regular x's with regular x's, keeping your x cubed alone and your constant alone because it does not have a like term. And then you're going to get your final answer here, making sure that you write it in standard form and you have your final answer there. All right, and here they're just showing you how multiplying a trinomial and a binomial is similar to multiplying a 3-digit number and a 2-digit number. Just like I showed you earlier, when I am multiplying, I have to multiply the ones place by every term on top and the tens place by every term. And you're kind of doing the same thing here with this binomial and the trinomial. You can do something like FOILing. It's more like the distributive property when you have a trinomial and a binomial. Just making sure that you're multiplying your 2x by each of these terms and your 4 by each of these terms, and then adding them all together and combining like terms. All right, we're running out of a little time, so go ahead and try this one right here, example 4. You can look ahead at example 5 and 6, but we'll have to go over those in class a little bit more. But good luck multiplying.